12.4 day 1, example 2, letter A. We're supposed to evaluate limits to find the derivative. Basically, we're just finding the derivative, and we're going to be using that power rule shortcut to do it. And then we're supposed to evaluate the derivative for the given values. In section 12.3, we found a formula for the slope of the tangent line. That's the same thing as the derivative. So we're going to find the derivative, but not do it the long way. Like we did in 12.3, we'll use the power rule. And then when we're done, we're going to have a formula that will find the slope of the tangent line at any point. At the end, they want us to plug these two numbers in. So this is exactly like example number 1, except we'll have to plug these two numbers into our final answer at the end. All right. F of x is equal to this trinomial. In order for us to use our power rule shortcut, we need to have x raised to a power, and we do have that for each one of these. Here's we have an x squared, here's an x to the first power, and really that's an x to the 0. So I don't need to change anything. I can just calculate the derivative, f prime of x. I'm going to do this in one step this time instead of laying it out piece by piece. When you're using the power rule, you take and you copy down the number in front, and then you multiply it by the exponent. So it would be a negative 5 times 2, which is a negative 10. And then we need to reduce the exponent by 1. 2 minus 1 is 1, so we would have a negative 10x to the first power, or just a negative 10x. Our next term is a number times x, and we said, using our power rule, if you have a number times x, when you do the derivative, it just becomes the number in front. And when you do the derivative of a constant, like minus 12, that just gives you 0. So I could put a plus 0 there, but this is it. That is our derivative. Again, if we were doing this the long way, using section 12.3 with that limit as h approaches 0, that big difference quotient, that would take me about 2 or 3 minutes. Using our power rule, talking through it took me about 20-25 seconds. So this is really fast. So here's our formula. This is the derivative. It is the slope of the tangent line at any point. And now they want us to plug in these two different x values. When we did 12.3, they gave us an ordered pair here, and we only plugged in the x's. In this section, they're just giving us the x's. So to finish this up, we need to calculate what is this formula when x is 1. So here's our general formula, and now we're going to see what happens when x is 1. When x is equal to 1, what we're going to be calculating is f prime of 1. We're taking 1 and we're plugging it in for x. So that becomes f prime of 1. And we plug the 1 in here too. So it becomes negative 10 times 1 plus 2, which is equal to negative 10 plus 2, or a negative 8. So f prime of 1 is equal to negative 8. The slope of our tangent line, when x is equal to 1, is negative 8. Those are all synonymous with each other. I'm also supposed to see what happens when we plug in 4. So now I'm going to take our general formula that I have here in blue, and I'm going to plug in 4 for all of those x's. That's going to be negative 10 times 4 plus 2. Negative 10 times 4 is negative 40, plus 2 is negative 38. So f prime of 4 is equal to a negative 38. Or if I say it another way, the derivative when x is equal to 4 is negative 38. Or if I say it more like section 12.3, the slope of the tangent line for our function at 4 for x is equal to 38.